have a company based in Canada. We're a manufacturer of odor measurement equipment, sampling equipment, sample bags, and we sell our products worldwide. So some of the products we make in-field olfactometers, the one you see on your left, and we make portable olfactometers, the one you see in the middle, and we make stationary olfactometers, like 6 people sit, and that's the one on your right. So the one we're going to use for this study is the one on the left, and I'm going to refer to it, the in-field olfactometer. We also make sampling equipment, so like Anna was mentioning, vacuum chambers. The gentleman before Anna was for static hoods. That particular static hood is designed to work with an in-field olfactometer, so the EPA one we sell is larger. Flux chambers and diluting samplers. So the issues that Anna was covering, you need to pre-dilute. That will be with that. Yes. I'm sorry. Okay. So we also sell some sample storage equipment, which basically means sample bags. And we sell PTFE sample bags, which is Teflon, Tedlar sample bags, and stainless steel. We also sell Nalophan, but the one that I'm going to focus on are the Tedlar, Nalophan, and PTFE. Now, why we have PTFE? It's because Tedlar is starting to be phased out by DuPont, and it has some drawbacks, such as Anna mentioned. You have background odor 100 times, or 50 times at least. So when you use it, you will already introduce some contamination. So the PTFE bag is cost about the same, but you have many advantages, and we're going to cover some of those. And just one other thing, I don't cover many aspects of field olfactometry here, but we have an online academy where it's free and you can take courses in different odor measurement, analysis, some things like that. So the objective of my study was to determine the effects of transportation, because in Canada, it's a big country like Chile, and distance between a laboratory and a job site might be 4,000 kilometers. So it's not where in Europe you have a dense population of laboratories and you have jobs 100 kilometers away. Here we have to travel with the samples. So what happens when we do travel long distance, and especially air freight? So in Canada and everywhere is a 30-hour, but everybody's sort of moving to the German 6-hour limit. So we just want to study what happens within that first 24 hours. And what we want to study is, what does the bag material have anything to do with it? Does it make a difference which one we use? And some good practices in our transportation. So the equipment we used, as I mentioned, was the field olfactometer. And we used it in a laboratory setting. So that means that you connect the bag to it from a sample source, like a stack, and a person sniffs, same as a normal olfactometer. Why we use this? Because we needed to analyze the sample right away. And the samples we were given access to were not close to our office, so we couldn't bring them back fast enough to get that 0 to 2 hour analysis. So the way the field olfactometer works is you have a gas cylinder which carries your air, and it goes through filtration, and the flow is regulated to try to match the EN standard to 20 liters per minute. And air is cleaned with an active carbon. Then it passes through an eductor, which creates a vacuum, and the vacuum pulls the sample. And you can change the dilution based on how you rotate the spool in the middle, so you can pick the different dilutions. So this is the equipment we're going to use for this. So the first study was to find out the background odor. So you have, as previous people mentioned, Nalophan, about 9 odor units, virgin Tedlar, or new one, 40 to 100. So the one we had was actually pretty low, 40. And if you precondition, you can get it down to 70. PTFE doesn't have any sample, any odor to it. If you just clean once with nitrogen, it will take away anything it has. So the second one was, what happens to the samples, let's say from a wastewater treatment plant, the first case. And this is at standard temperature, standard. So we just put it in a laboratory, and we did analysis from 0. So our 0 is about 10 or 15 minutes after sample finishes to 24 hours. And you can see a drop with PTFE performing slightly better, but sort of a similar, everybody's kind of dropping. Some samples, so depending on what sampling, if you're sampling from poultry or you're sampling from an agricultural source, then Nalophan has a different behavior. It starts to lose odors faster. Tedlar and PTFE, very similar. So in my paper, I described some of the chemicals that I think might be responsible for this difference. Now, another very interesting one, and this is because in Canada we have a lot of oil refinery, is for benzene and other oil products. So what happens is if they are in Alberta on the west coast and they send it to east coast for analysis, look how much drops they have, like 10 times or 5 times. And this is without air shipment. This is just at standard conditions. So we wanted to investigate this a little more. So we send the bags to the lab where they do analysis not based on odor, but based on ppm of benzene. So what they get is that after just 10 minutes, so this is fill the bag, go to the analyzer, in the Nalophan bag, you lose half of your benzene. And 45 minutes, 35% is left. In Tedlar, a little bit better, but even within 45 minutes, half of your benzene is gone. In PTFE, okay, a little bit better, 85% is still there. So for some chemicals, you have to be careful. Like benzene, you should definitely use a material which has a high density, like PTFE, or use stainless steel bag or sumo canister. You cannot transport this material using Nalophan. So another aspect is what happens when we ship something. When we ship it, we subject the sample to drop in pressure and drop in temperature. So this is a key issue. Sorry, this thing is sensitive. So if you see on the left-hand side, you have at standard temperatures and the behavior of the odor loss. When you look on the right, all the lines start to drop much faster, especially within the first 2 hours. So what we did here was we created a vacuum about 10%, and we created a lower temperature of 13 degrees Celsius, which in Canada is not hard to make cold temperature. So when we analyzed them, we found that if you air freight something, it loses its odor much faster than if you send it by truck. Then the last one is something to do with cross-contamination. So it's a good practice. And what it means is that if I put a bag of 10,000 odor units in with a bag of 10 odor units in the same box and close it, well, they're starting to mix together. And by the end of it, you have something that is 5,000 odor units and 2,000 odor units. So they will start to cross-contaminate. So we have to be careful to avoid this. And most sampling, good samplers, know to separate these kind of sources. And the separation should also be based on the type. So if you took benzene and wastewater, okay, nobody does, but just as an extreme example, don't put them together. Otherwise, you get a chicken benzene kind of smell. Right, like they can even increase in odor from the original one. So we put the 2 samples in a carton box, and we start to measure the outlet one, which was the high one. So you see they all start to, the low odor unit. So they all start to increase in odor unit. They started out at somewhere around 50, and they start to increase to like 600. The inlet or the strong sample starts to decrease. So it's important to separate these ones. And then we did some study on the headspace of the carton. So if you put in a carton about 8 odor units to 30 odor units you have of contamination. But if you put them together, the contamination will rise, and you will have a carton which is basically contaminated, and it's contaminating your weak samples. So, in conclusion, 1, samples should be analyzed as fast as possible. This may not be feasible in some countries where the geographic is huge, Australia, Canada, Chile. If you use PTFE, because of its density, it has a better holding time in most cases than Nalophan or Tedlar. When bags are subjected to low pressure and temperature, they lose their odors. So try to keep them from air freight. And another important thing is not to overfill bags, because when you air freight something, it will start to be pressurized inside the sample. So only 80% should be filled the sample bag. And then, as I mentioned, samples of different concentrations should be stored together, not separated, not together. Otherwise, they cross-contaminate each other. If you have more than a few hours of transit, it's better to use field olfactometry. You lose some accuracy, perhaps, from your laboratory olfactometry, but the amount of odor loss is so huge that 10% or 20% difference might not be at all noticeable compared to 10 times or 20 times drop in odor. So in Canada, for example, all the West Coast is now mostly on field olfactometry. So that's the end of my presentation. And if you have any questions. Oh, if you put in... Yeah, the study I did was on cargo planes. You still have a pressure difference. Like if you notice your water bottle, when you land after you opened it, it's crushed. So you do have some, but how much can you take with you into a passenger? Like, if you have triplet samples, 10 liters each, they're going to be quite... So it is better. And some companies, for example, we did a study with FedEx. So we pulled data from FedEx. But I know like TNT, for example, their planes are better pressurized than FedEx. So it just depends on some. But you will still lose based on that.
Any other questions?
Thanks for the presentation. PTFE performed better than any other chemicals or any other material?
We compared to Tedlar and Nalophan. I didn't compare it to stainless steel, for example.
What's the market status or the market share of that material? Why shouldn't we just be using that one?
Well, in Canada, now almost all our consultants using PTFE. Now, I tell you why it wasn't before. PTFE is not a new material. We've had Teflon for 30 years. The problem was to weld the Teflon back so that you have a good seal and stuff was a very complicated process. So we developed a machine to weld this back so we can give it at the same price as before. Before, it was 4 times as expensive, so nobody wanted to implement it. But now that we're switching, almost everybody in our vicinity has already switched, and we ship to Australia, quite a few. We have some in Chile here using it as well. So it is better, and I had some samples. I hope by tomorrow they arrive. They're stuck in Chile customs. And 1 liter samples, and I encourage you to take and try, or you give me a business card I can send you, to try on your own process and see how it behaves. Everybody usually, once they switch, they don't go back to Tedlar. And the other reason is that you can reuse, because Teflon is a non-stick material. So the molecules on the surface are easier to clean. So you can reuse your Teflon back 50 times if you properly clean it. Where Tedlar you can, but you need to really clean at high temperature, and the cost of energy might be more than the bag itself.
I have a question if no one else has.
Oh.
I assume all these samples were analyzed in-house, in your laboratory.
Well, no, because, like I said, we had to do very quickly. So the rendering plant or something like that was not very close to us. So we made a makeshift kind of laboratory close to the plant. So we took it from the plant, go to this off-site laboratory and use the field olfactometer.
My main question is because would it be possible that the differences that you noticed was due to the analyzing uncertainty?
There is some analyzing uncertainty. Now, we ran the sample 3 times and averaged it out. There is some uncertainty, of course, with any olfactometry. But if it's the same person doing it again, the sample uncertainty is not going to be 10 times. So when you see Nalophan at the bottom with 20% of the odor left and the other one 80%, that's not with the uncertainty of the olfactometry. That is a trend.
But what's the uncertainty of an accredited lab, an accredited one?
Accredited lab, the uncertainty is different because when you consider a lab, you have to consider different panelists running. You have to consider different days that the panelist is running. So you have a lot of factors that change by the day. So if you send the same sample 2 days in a row, you get completely different people, different maybe operator. Here,
that's against any standard, isn't it?
Pardon?
The idea of having a standard is to
Yes, but-
reproducibility and
Yes, they reduce it,
to
right?
be traceable.
Yes.
That means that another unit in China is the same than another unit in Chile.
Technically, older unit in China is not the same because they follow a different rule, but yes.
Well, if you use the same standard,
No. They
it
use
should be the same.
No, they use, I can tell you, because our olfactometers are sold a lot in China, they use reverse dilution. So you start with giving the people strong odor and go backwards in an elimination kind of round robin of eliminating people as they get it wrong. So it is completely different, and what they get is not an odor unit at all. I'll be happy to describe. It's an interesting way of looking at it. But now at the question of the uncertainty, when you consider uncertainty as the laboratory over many days, considering many panelists and such things, it has a bigger uncertainty than if I sit down and do the same test twice in a row. So the uncertainty in doing it twice in a row is not 50% or 100%. The uncertainty then is much less. Right? So if I give you n-butanol twice, you will get closer results than if I give it to you in 3 days or if I give to different people. Right? Does that answer the question, sort of?
I think we'll
No,
move on to
it
the
does not.
next
You can
question.
say no. It's
we'll
okay.
move on to the next question.
Okay, we can discuss later. I'd be happy to show the results. And
Yeah, why not? Sure. we'll do that, but in the meantime, we're pressing on time, so we have to give the word to Hector. But thank you very much.
Thank you.